Welcome to lecture 31 of the course CS213 Object-Oriented Programming of the Cohort University of Science and Technology. In this lecture we will talk about how to work with files in Java, and we will see how we can read from the file, how can we write to a file in Java, and we will look at how we can perform file input and output operations in Java. You can find the details in chapter 15 of the relevant book, and there will be a list of resources given if you want to go into more details. We'll be covering the basics of file input and output operations in Java in this lecture and in the upcoming lecture. But if you want to know more details, then there will be resource provided to you at the end of this lecture, or maybe the next lecture. The goals of these lectures are that by the end of this lesson you should be able to retrieve metadata about files and directories with Java. You should be able to write text to and read text from text files, and you should be able to write serialized Java objects to binary files and read such objects from file. And you should be able to write and read by arbitrary binary values to and from binary files. Files and streams in Java. Files in Java are simply streams of bytes. Writing a file means opening a stream and writing to it. Reading a file means opening a stream and reading from it. And it is purely byte based streams and are called binary files. Often when we will interact with text files where the underlying byte stream is made up of characters, each of which is made up of 2 bytes. The size of the character type in Java, the byte is the size of a character in Java, and we are mostly dealing with characters that are stored in the form of bytes in Java, and that is why we will be working with purely byte-based streams, and these are called binary files. Interactions with files and directories takes place via the packages. We have java.io, which is Java's traditional IO classes and interfaces, and then we have java.nio, which has Java's new input-output classes and interfaces. The path class provides static methods that let us create objects implementing the path interface. For example, if we look at this code, we have the scanner class object keyboard input, and then we want to for example, if you want to read a file name, then you enter the file name and you can get that name using the get method, that is the static method of the paths class from this input that you provide through the keyboard. Objects with the path interface let us query, manipulate, and convert paths. For example, if you want to convert the name of a path to a string, you can do this path dot get file name. You can convert it to a boolean. For example, you can store it in a boolean object. If you want to know if it is an absolute path, then you can convert a path to an absolute path. We'll see what are absolute and relevant paths. The files class provides static methods that let us access information about objects with the path interface. So we have another class called the files class along with the paths class, and the files class provides static methods that lets us are the methods that let us access information about objects with the path interface. For example, if you want to know if a path exists, so you can call the exist method of the files class. If you want to know if a given path is a directory, you can then use the isDirectory method of the files class. And if you want to know the size of the path, then you can call the size method of the files class. These are all static methods. And if you want to know any timing of the path, that when the path was modified, then you can use the get last modified time of the files method. If you go into the documentation of these classes, then you can find more methods. For example, we have a directory stream kind of an array list collection that a directory stream object provides an iterable data structure of objects with the path interface. So for example, if you want to store a list of paths or directories, then you can use the directory stream where you can have a list of paths or directories, and it works like an array list, so you can store multiple paths in this object. If you look at a sample code of writing to a text file, we will also look at our code in NetBeans of how we can write to a text file. But to look at this code, we have to import these libraries. For example, we need to import these classes. So we have the formatter class. We create an object of the formatter class, and then we pass the name of the file that we want to write to the formatter class in the constructor of to the constructor of the formatter class. We also use exceptions. For example, if you cannot write to a file, or if you want to ensure that the path exists or the file exists, then you need to handle these kinds of exceptions. For example, if you are not allowed to write on to the file for security reasons, or if you are not able to find the file on the given path, then you need to handle these exceptions. These are the common exceptions that a programmer should know about, that whenever you are dealing with files, then these are the kind of errors that you can face. Then you can simply use the format method and the kind of format that you want to use for your whatever the string or integer or any other data that you are writing to the file. You can pass those string. For example, if this is a given string, then you write the string to the file. The output is as the object that will where we have stored this file. Then this will write the string to the file in this format. If you want to write another string, it will write another string in the next line. If you want to write an integer, you can use the format method. And then you need to remember that we need to close the file to be able to save the text to the file. Unless and until you close the file, your text won't be saved to the file. The formatter class opens a text file for writing or overwriting. So if you write to the same file, then it will overwrite your previous file. Multiple calls to the format method do the actual writing, much like a printf. Like for example, we were calling the format method over here to write to our file. So we can use the format method to write to the file. After writing, we need to close the formatter. So we need to remember that unless we close the file, we won't be able to save our data or our text to the file. Now let's look at the sample code for how we can read from a text file. Reading from a text file is quite easy. We have been using the scanner class and an object of the scanner class to take input from the user. Similarly, we can use the scanner class or an object of the scanner class to read from a file. All we need is to get the path of the file using the paths, the get method or the static method get of the paths class, and provide the path of the file, and we store this information in the object of the scanner class. And then we can go through the object and read the text from a text file line by line. We need to remember that we need to handle the exceptions, and the most common exception that you can face is if the file does not exist or if it is not readable. So you should remember to handle the exceptions. So you go through a loop, you use a loop, a while loop in this case, and that has a next method of the scanner class, which looks into the file. If it has more data left, then it reads that data line by line into an object of or a string, and then we can do whatever we want to with the text. We can print the text on our program, or we can extract some useful details from the text if you are working with files, and then um, you can close the file after you have read the data from the file. Reading from the text files, open a text file with an object from our well-known scanner class. The same methods such as next or next line, etc., that work for input streams from the console work for files too. So we have used these methods, for example the next method or the next line method, to take input from the user on a console based interface. The same can be used to read text from the text files. The hasNext method checks whether there is any data left in the file that we haven't read yet. We will look into an example of how we can store image names of our photo album application. We will have a photo album, want to create a photo album application, and we want to store images with their names, captions and paths to the image files in a text file. So we want to store these details in a text file. So the simple concept is one photo record per line. We want to store the details of one photo in a single line on our text file with the different photo properties separated by commas, and the properties of the photo should be within the same line, separated by commas. But what do we do if a name or a caption contain commas? So if the name actually contains a comma, then we can use the backslash. Put a backslash in front of the comma so we know this is not a separator comma. For example, this in this case is a separator comma, but if we have a comma that is actually part of the name, then we can use the backslash with that comma. But what do we do if a name or a caption spans multiple lines? Again, the answer can be we can again use the backslash escapes. Writing such files is easy, reading may be a little harder, and we'll need to go back to the regular expressions and how we can use regular expressions to read from a file. Binary files and objects. A common task in file input-output operation in Java applications is to save objects to files. Turning an object into a sequence of bytes that can be written to a file is called a serialization. That process is called a serialization. We need to convert an object into a sequence of bytes. Since earlier part of the lecture we talked about how we are working with basically with bytes or binary files when we are writing to files in Java. We will assume for simplicity that our objects classes will have no static variables. To be able to serialize an object, its class must implement the serializable interface. So we will be implementing the serializable interface to be able to serialize an object, and we need to serialize an object to be able to write the to those objects to the files, because in the process of serialization you are turning an object into a sequence of bytes. This is a so-called tagging interface. Tagging interfaces are interfaces that have no methods. This means we don't have to implement any methods, provided all of its instance variables are either primitives or implement serializable. So we are not dealing with the static variables. We assume that all of the instance variables are primitives or they implement serializable. Tagging interfaces are mark interfaces are the interfaces that do not have any methods in them. So if we look at this code, this is the code where we are trying to write the details of images along with the paths and the names into a text file. The class implements the serializable interface. Since the image is not a serializable but image icon is serializable and it contains an image, it can contain an image, so we can convert it into bytes. We need to import the required classes and interfaces that we are implementing or using in our code. So we need to identify which field should be serialized. We have this final static array and we store all of the elements or all of the variables that we want to serialize in this array. If we have non-serializable instance variables that need to be packed up before or restored after serialization, we can implement these two methods in the class to assist us. So we have the write object, for example, where the image is not serializable. We save full size image to a new icon to store. Remember, image is not serializable but image icon is, and image icon revs an image. So icon stores the image. As we can see over here, we can call the set image method of the icon image icon class and store it in the icon variable or object of the image icon class. And then if we need to read the image, so this method gets called upon deserialization. This process called we deserialize the image from the icon into an object of the image class. And we need to remember to handle the exceptions over here. And we can see that we are using the object input stream, an object of the object input stream over here, and we are using an object of the object output stream over here when we are writing to the file, and when we are reading from the file we are using an object of the input stream. So stream.default read object calls the default constructor, and we read the additional configuration. We read the image or restore the image from the icon into an object of the image class. Since the image was not serializable, we pack it into an object of the icon class, and then when we need to read the image again, we unpack it or deserialize it from the object of the icon class to the object of the image class in this code, in this method. A default constructor is required for deserialization. It needs to initialize all serialized fields. So these were the details of for each image that we are saving, and these were the fields that we serialized and saved to our file. We have the path, we have and these are initialized to their default values, and then we need an overloaded constructor for use in our application. So we get the absolute path, we get the image icon from the path, and then we get the image from the icon into an object of the image class, get the name of the image, and there is the caption. Opening an object output stream. Step 1, open file for writing with an object output stream. So here we are opening a file, we are passing the path of the file, and this is the file that we will read our data or write our data to, our output to. So we have an object of the object output stream. If you are using more data, for example, you can use the data output stream, but here in this case we will be using the object output stream. And then we have the new output stream method of the files class, where within that method within the parenthesis of that method we call the get method of the paths class to get the path of the file where we are writing the details, and we need to handle the exception if the path is not found. The object output stream constructor throws an IO exception if it is unable to open the file for writing. Path to the file does not exist, or file is read only. In this case our album can continue to run, we just can't save the images for a later startup. So we won't be able to save the images if we are handling the exception, but our program will continue to run. You can add a pop-up notice, for example, maybe add a dialog box that displays this message if the file is not found. Writing to the object output stream, we write all entries to a file and need to rewrite the whole file. For example, we use a loop over here, and then we use the output object that we created on our previous slide to write all of the images one by one to our file using the write object method, and we pass each method one by one, each image one by one, and we write that image detail to our file. The write object method also throws an IO exception if it is unable to serialize the object passed to it as a parameter. In this case our album can also continue to run, we just won't save the images again. If the objects and images are not serializable, then this is a problem with the code, not the file system. That is, there is no point telling the user if you as a developer need to fix it. We need to remember that we need to close the file to be able to save our file and what the data that we have written to a file. This is the last step. Only by closing the object output stream can we assure that the file is truly closed. And this is especially important when we write to files that are on external media such as USB sticks. If we want to read from the file, we can use an object input stream object So we initialize the object to null and then we assign the path to it using the new input stream of the files class, and we get the path of the album. We need to remember that we need to handle the exception. The object input stream constructor throws an IO exception if it is unable to open the file for reading. For example, if the file to the path doesn't exist or no read permission for a file. In this case, our album can also continue to run. We can't read the images. And the challenge is if you can add a pop-up message, for example, to display a message in the a dialog box to the user. Reading from an object input stream, we use the while method as long as there are objects in our file. We keep reading those objects, and we keep storing them one by one in this object of our album image class, and then we keep adding those to the images object. You should note that we have to take care of three possible exceptions here, one of which is actually used for flow control. So we need to have an end of file exception. We keep reading the images or the details of the images into our object as long as there are images in the file, and we can have class not found exception if you do not find the album image class, or if we are not able to read from the file, but we need to have this exception over here if we reach to the end of the file. And we need to remember that we need to close the file once we have read from the files. We need to close the object or the stream or the object of the object input stream that we created earlier. So often we'll need to write or read binary files that don't contain serialized Java objects. We can do so by using a data output stream instead of an object input output stream. We can use a data input stream instead of an object input stream. Opening these streams is identical to their object versions as we just saw in the example. When writing to a data output stream, we need to decide in which format we want to write the data. Methods available include write_byte, write_end, write_double, etc. There are too many to list over here. We can have other reading from a data input stream is done analogously with the methods such as read_byte, read_end, read_double, etc. that return values of the respective types. And what we do know so far is the Java classes paths, files, and directory stream give us access to metadata of the files and the directory structure. The formatter and scanner classes let us write and read text file data. Regular expressions can help us parse input, and we'll be looking at some of these examples of working with the files in our lecture. We will be looking at practical examples. Objects of classes that implement the serializable interface can be stored sequentially in binary files, and implementing the serializable interface does not mandate any methods, but we must ensure that either all instance variables in the object are serializable, or we need to specify which ones are to be serialized with the object. So as we said that this is a tagged interface which has no method to implement, but we only can work with the instance variables that are serializable, or we should be able to pack and pack the objects into serializable objects or bytes if they are not serializable, as we did with our image. Serializable classes need a default constructor and may implement the write object and read object methods to ensure correct serialization and deserialization. We can write and read arbitrary binary files with data output stream and data input stream. Exceptions are being thrown all over the place, so we need to handle the exception. We need to remember that we must be handling all the exceptions that may come our way. And these are the resources that we can you can look into if you want to know, go into more detail of how of reading and writing in into files, or reading from the files or writing into files, and some of the documentation of these important classes. So if you want to know more details, you can go into these, follow these links. I will conclude our this part of the this lecture over here, and we will look at practical examples of reading and writing from the files in the next lecture.